We are finishing up linear systems with a whole bunch of word problems. So I'm going to go through a variety of them. This first variety is called two numbers. And because they usually talk about two numbers within the problem description. So let us look at one of these problems. And here we are. 3 times larger of two numbers. That's why this is called a two number. Is equal to 4 times the smaller. The sum of the numbers is 21. Find the numbers. Well, what do you want to call it when you don't know what it is? And frankly, the hardest part in this whole system is just labeling the numbers. So let's let x equal the larger number. And it's a good idea to put the label on your paper. That means that y is going to be the smaller. Now, how do we translate English to math? 3 times the larger. Well, we called x the larger, so a way to say 3 times the larger is 3x. 3 times the larger of two numbers is means equal. Is equal to 4 times the smaller. Well, how do we say the smaller? We said it with a y. How do we say 4 times the smaller? 4y. The sum of the numbers is 21. Well, what do we mean by the sum? That means to add. So we're going to add those two numbers, and x plus y equals 21. And then the question becomes, how do you want to solve this system? Well, this is very similar to the substitution problems we used, and indeed, we could get x or y by itself very quickly. So I think I will do that. I will rewrite this second equation as x equals 21 minus y. And then I'm going to take what x is worth and put it in the first equation right there. So then I can rewrite that equation with an x, 3 times, now when you make your substitutions, be sure to make them in parentheses, put them in parentheses, equals 4y. So 3 times 21 is 63 minus 3y equals 4y. I have a linear equation now in one variable. How do I solve it? By isolating the variable. But the first thing I got to do is move all the things with variables over to one side. So I'm going to add 3y to both sides. Then I have 63 equals 7y. Therefore, a y must be equal to a 9. Have I found both numbers? No, I've only found one. So let's see, the sum of the numbers is 21. So if one of them is 9, then what must the other one be? Or excuse me, we found y. So let's back that out a second. And so x plus 9 equals 21. What can you add to 9 to get 21? And the answer is 12. So x is equal to 12. So our two numbers are 12 and 9. 12, 9, like that. Now, because we really weren't told whether we should call them x or y, this order isn't as crucial. And I think in the answers column, you're just looking for 12 and 9. That is a pair, and they're not listed in parentheses or anything. Okay. All right. Oh, what did I do here? All right, let's go back to my background. Whoops, background, and I gotta fix a problem. All right, that was part 1. Let's go to problem 3. In problem 3, I have two numbers again, and I have a larger number and I have a smaller number. What do you want to call them when you don't know what it is? Well, let's be careful again and label these numbers. So let's let x be the larger and y be the smaller. You know, on your test, if you give me labels, I will give you at least 1 point for trying to tackle this kind of a problem. So now we know which one's larger. The larger of two numbers, well, how did we say that? We said it with an X. The larger of two numbers is 1 more than, so 1 added on to, twice the smaller, 2y. The sum of the numbers, x plus y, is 20 less than. Now this 20 less than piece comes after the next phrase. That's just how we handle it. 3 times the smaller, so 3y minus 20. There's your equation. And we've got variables kind of scattered on both sides of the second one. So let us, we could use substitution right away on this one if we wanted to. But let us just combine some terms here. I'm going to take a y off of both sides, so it reads x equals 2y minus 20. And then in place of, I could use substitution because x is worth that much. I could plug it in down there. Or since x is worth that much, I could plug it in up here. Or since x is this and x is that, I could set those two expressions equal to each other. So there's several different ways you could approach solving this equation. I'm going to leave it like that. I'm going to let you figure out what to do from here. So closing that up, let's go to another one. A group of students go out for lunch. If 2 have hamburgers and 5 have hot dogs, the bill will be $8. If 5 have hamburgers and 2 have hot dogs, the bill will be $9.50. What is the price of a hamburger? And by the way, this is probably in 1984 dollars when this was written. So, what don't we know? We don't know how many bought hamburgers. So let's make some labels. Let's call H is equal to students who ate hamburgers. And let's call D equaling the students who ate hot dogs. Okay. Then we go back, now that we've got our labels, now we can go back and read for equations. If 2 have hamburgers, well that's 2H, and 5 have hot dogs, so 2 hamburgers and 5 hot dogs will be $8. That's 8. Okay? And we can go ahead and put it in dollars if you like. If 5 have hamburgers, 5 hamburgers, and 2 have hot dogs, the bill will be $9.50. Okay, you may decide what to do with this. I would multiply and add, and your common multiple for either H's or D's is going to be 10. So, have at it. That's how you work out two number problems.